Precalculus Review, Part 2, Polynomial Division and Rationalizing the Denominator. This format I obtained from Canadian math YouTuber Jeremy Clausen, and several of these problems I invite you to consider looking at his YouTube channel. For my students, I consider to have you work along with the accompanying worksheet if you have one, and in any case, if viewers can work ahead as much as possible, you'll get more out of this video lesson. Okay, we have this first problem here, 2x squared plus 6x minus 20 over x plus 5. We're going to start out by looking kind of at the anatomy of a division problem and different ways of representing division problems. This horizontal line segment is called a division bar. And there's another name for this as well, and that name is called a, I'm putting parentheses here, a vinculum. Now, if this word isn't familiar to you, don't worry about that. I didn't know about this word either until 9 years ago when I was trained by my mentor, Tracy Etheridge. So that's one thing here. In the numerator, what we are dividing is called the dividend. So that's going to be this quantity here. What we are dividing by in the denominator is called the divisor. And when we calculate our answer is called a quotient. Now, always in checking our work, we can, if we take our quotient and our divisor, and multiply these two expressions together, we're going to get our dividend. So I put this here as a way of checking our work. Now, there are other ways of writing this particular division problem, one of which is if we take inside parentheses 2x squared plus 6x minus 20, all wrapped inside parentheses, and put a division symbol here, and then wrapped in parentheses the denominator x plus 5. Now, why did we not need parentheses in our original format here with the division bar? Because division bar presumes that the numerator and denominator separately contain parentheses. Another way of writing out this problem is writing this out as a long division problem. We put the dividend inside the long division bracket, which is 2x squared plus 6x minus 20, and the outside of the long division bracket we put x plus 5. Now, there are yet other ways of representing a polynomial division problem. Here, verbally, if a dividend is 2x squared plus 6x minus 20 and a divisor is x plus 5, what is the quotient? And then this can be worked out as a real-world problem where we have a rectangle represented by an area of 2x squared plus 6x minus 20. So I'm going to put here 2x squared plus 6x minus 20, and its width is x plus 5. Find an expression for its length. And so we have this formula for area equals length times width, and we can instead solve for L, and L, the length we're trying to solve for, is the area divided by the width. So this is a real-world application, if you can call it that, of this particular problem. Now we're going to go work this problem out. Now the easiest way to work out polynomial division problems, if you can do it, is by factoring and canceling. So in the denominator we bring over x plus 5, and if we can separate this quadratic trinomial into two linear factors, that's going to make this easier for us to do. And it's going to be very convenient if one of the factors of the numerator happens to be x plus 5. So this is a strategy. If you see this type of problem worked out here, you can just try and see if you can get what is in the denominator as a factor. So now we ask ourselves the question, what times x equals 2x squared? Well, that's going to be 2x. And what times 5 equals negative 20? Well, that's going to be negative 4. And we can check our work here, see if this works out right. If we put 2x minus 4 times x plus 5 and make this double smiley type of arrangement here, we put negative 4x, negative 4 times x, and 2x times 5 is going to be plus 10x, and we add these together and we have 6x. So this shows that we have a proper factoring here, and these will cancel each other. So our answer is going to be 2x minus 4. And so 2x minus 4 is equivalent to the original polynomial division problem here, except there's something missing. We cannot divide by 0 in math or in algebra, so x plus 5 cannot equal 0. So therefore x cannot be equal to negative 5. So a proper solution is not going to be only this 2x minus 4, but also the condition, comma, x cannot equal negative 5. So that would be our answer here. Now before we go on to the next problem, I want to go back to our real world example here. And we have found from the prior work that our length is going to be 2x minus 4. And so our answer here is going to be 2x minus 4. But one thing we have to concern ourselves with is, in the context of this being a rectangle, we know that our width, both our length and our width, have to be positive numbers. So x plus 5 has to be greater than 0. And subtracting, x has to be greater than negative 5, which is different than x cannot equal negative 5. And also our length has to be a positive number, so 2x minus 4 has to be greater than 0. And if we add 4 to both sides here, 2x is going to be greater than 4, and dividing by 2, x is greater than 2. So x has to be greater than negative 4, but also x has to be greater than 2. And so that's going to rule our situation here. So our condition in this particular instance is going to be x is greater than 2, because otherwise the problem would not, the answer would not make sense. So we have to look at these things, real world situations. Okay, next we'll look at problem B. We have 2x cubed minus 3x squared minus 11x plus 6 over x plus 2. And now we have a situation where our numerator is not as easily factorable. So we're going to use something called polynomial long division. So if we rewrite this problem in a long division bracket, inside the dividend place we put 2x cubed minus 3x squared minus 11x plus 6, and in the divisor space here on the outside we put x plus 2. And now we just work below. We take 2x cubed divided by x is 2x squared. 2x squared times x is 2x cubed. 2x squared times 2 is going to be plus 4x squared. And now we're going to subtract and work down here. 2x cubed minus 2x cubed is 0. Negative x squared minus 4x squared is negative 7x squared. And we're going to bring down this negative 11x. And so we have negative 7x squared divided by x is negative 7x. Negative 7x times x is negative 7x squared. And negative 7x times 2 is going to be negative 14x. We're going to subtract negative 7x squared minus 7x squared minus negative 7x squared is 0. Negative 11x minus negative 14x is going to be positive 3x. And that's where our integer arithmetic is crucial. We bring down this plus 6. 3x divided by x is 3. So we put plus 3 here. 3 times x is 3x. And 3 times 2 is plus 6. And we subtract out this quantity and we get our remainder of 0. So in this case our answer, which is our quotient, and I'm going to put down quotient just for specificity, quotient is going to be 2x squared minus 7x plus 3. But is that the totality of our answer? Well, we got to worry about this divisor again. X plus 2 cannot equal 0, so x cannot equal negative 2. So our condition here, we put comma, x cannot equal negative 2. Now another technique that, where feasible, is very helpful is something called synthetic division. So I'm going to work out the same problem, but using synthetic division. And what we have to do for synthetic division is set up some kind of bracket. I like using this sort of long L bracket. And we have to put on the outside of the bracket the number, the value, the 0. So we put our denominator here, x plus 2, and set that equal to 0. And so x is equal to negative 2. So negative 2 is the number that goes outside the synthetic division bracket. On the inside we put the coefficients of the dividend. We put 2x cubed minus 3x squared minus 11x and plus 6. And we bring down the 2. So 2 goes down here. And this is what's called the x squared place. Now negative 2 times 2 is negative 4. Negative 3 plus negative 4 is negative 7. And this is going to be the x place. And then we take negative 2 times negative 7, it's going to be 14. Negative 11 plus 14 is 3. And this is going to be the number place, and I'm going to call this integer place. I'm going to abbreviate integer place. And negative 2 times 3 is negative 6. And 6 minus 6, or plus negative 6, is 0. So this is what's called our remainder place. Remainder. And so our answer is going to be the same. 2x squared minus 7x plus 3. And x cannot equal negative 2. Okay, let's go on to problem C. Here we have x cubed minus x minus 6 over x plus 4. I'm going to try to rewrite this as a polynomial, not a polynomial long division problem, but a synthetic division problem. So we know that x plus 4 is equal to 0 is the value of the 0. So working out our synthetic division bracket, we put our negative 4 outside here, and we put the coefficients inside here, which is going to be 1x cubed minus 1x minus 6. Now, is this a correct representation? Well, let's go ahead and look here. If we take the number 424, I ask you, is this number 424 equal to 4024? No, of course it isn't. And the reason it isn't is because we have on the right side 0 represented as in the hundredths place, and we don't have that 0 in the number to the left. And so what we have to do is make sure all the places are represented, so that the true representation is this one down below, which is negative 4 again on the outside, and on the inside we have 1x cubed, 0x squared, negative 1x, and negative 6. So we just work below here. We bring down 1. Negative 4 times 1 is negative 4. 0 plus negative 4 is negative 4. Negative 4 times negative 4 is 16. Negative 1 plus 16 is 15. Negative 4 times 15 is negative 60. And negative 66 is our remainder. So how we answer this question here, and one thing is, we know that x plus 4 cannot equal 0, so x cannot equal negative 4. So that's going to be a condition here. Okay. Well, our answer, our quotient, we can write this a couple of different ways. One way is x squared, 1x squared minus 4x plus 15, and you'll see sometimes remainder negative 66. And I don't like this way because it's really not as clear an explanation. I like to put this in the terms of summary statement, where it's just clearer. And the summary statement would be like this: x squared, very similar, minus 4x plus 15, and we would put minus our remainder over our divisor, and with the condition, comma, x cannot equal negative 4. And we do it for the one above here. I just put this both ways because sometimes you'll see it in different ways. Okay, the next and last polynomial division problem we'll look here in this exercise set is this one here. And we do not have we don't have a binomial in the denominator, this x cubed minus 1. We are going to have a hard time using synthetic division for this. But let's go ahead and look at our excluded value first. We know that x cubed minus 1, our denominator, cannot equal 0. So adding 1 to both sides here, x cubed cannot equal 1. And taking cube root of both sides, x cannot equal 1. So that's our excluded value. So let's work this out as a polynomial long division problem. So I'm going to go put this out here. In the divisor place, we put x cubed minus 1, and in the dividend place, what do we put there? Well, we're going to put this in standard form. We have to have the places right. Well, negative x and x will cancel each other, and we have to put in standard form on the inside. So we're going to put our x to the 4th power first, negative x to the fourth plus 2x cubed. And we have to look at all the places represented. So we have plus 0x squared plus 0x plus 0. So there we are all ready to do our polynomial long division. So negative x to the fourth power divided by x cubed is going to be negative x. Negative x times x cubed is going to be negative x to the fourth power, and negative x times negative 1 is going to be plus x. And we're going to subtract everything here. And when we subtract, we get 0 here, and then we have 2x cubed minus 0, because that's going to be plus 0x cubed plus 0x squared. Okay, just in case we miss out. So we're going to have 2x cubed here, and we're going to have 0x minus x, which is going to be negative x. And so we can go ahead and divide out, well, what is going to be 2x cubed divided by x cubed? Well, it's going to be plus 2. 2 times x cubed is 2x cubed. And we're going to have negative 2, or 2 times negative 1 is going to be negative 2. And we subtract out here, and we bring down this plus 0. I forgot to do that. So we subtract out here, we have 2x cubed minus 2x cubed is 0. Negative x minus 0, that's going to be negative x. And then we have 2 minus negative 2 is going to be plus 2. And we cannot divide any further, so this right here, negative x plus 2, this is going to be our value of our remainder. So our summary statement form is going to be, okay, I'll put summary statement. That's going to be negative x plus 2 plus our remainder, which is negative x plus 2 over our divisor, which is x cubed minus 1, comma, x cannot equal 1. So this is going to be our answer to this problem here. The next section we're going to look at is rationalizing the denominator. It's conventional in algebra to not have a radical in the denominator whenever possible. So we have 6x squared divided by the square root of 2x. So to get rid of a radical, we can get rid of it by multiplying it by itself. So the denominator, if we multiply by the square root of 2x, and we have to do the same in the numerator, square root of 2x, because what we're effectively doing here is multiplying by 1. We're going to look at the excluded value later, and just working below here, what we have in the numerator is 6x squared times square root of 2x, and in the denominator we have 2x. Well, 6 divided by 2 is equal to 3, and x squared divided by x is equal to x and times 2x. Now, do we have any excluded values here? Well, yes, we have. Now, we cannot divide by 0, but also we have our radical cannot be negative. So 2x has to be greater than 0. So therefore x has to be greater than 0. So that's going to be our condition here. So our answer is going to be 3x times square root of 2x, comma, x is greater than 0. Okay, let's go on to our next problem. We have x squared minus 4 over square root of quantity x minus 2. And so x minus 2 has to be greater than 0, and therefore x has to be greater than 2. So that's going to be our condition. So let's work below here. We have, well, let's go ahead and multiply this out first. To get rid of our radical in the denominator, we have to multiply by itself, which is going to be x minus 2, square root of x minus 2. In the numerator, we have to do the same. Square root of x minus 2. And we have to, since we move this in place, we have to also put x squared minus 4 in parentheses. Okay, so what we have left is this value, x squared minus 4 times square root of x minus 2, and we're going to divide this by x minus 2. Now, can we simplify this any further? Yes, we can take this x squared minus 4 and rewrite x minus 4 using a difference of squares. So we can rewrite this as x plus 2 times quantity x minus 2, and it's going to be times, of course, square root of x minus 2, and then we're dividing by x minus 2. And x minus 2 over x minus 2 cancel each other. So what we're left with is, in the numerator, we have quantity x plus 2 times quantity square root of x minus 2. And we have the condition x has to be greater than 2. So this will be our answer to this rationalization and simplification. Now, C, this is the last one we're going to do. And this time we have a greater degree of complexity in our denominator with this square root of x plus 4 minus square root of x. Well, before we work this out, let's look at our excluded values here. We know that x plus 4 has to be greater than 0. Okay, that's greater than 0. So x has to be greater than negative 4, and we know that x has to be greater than 0. So between these two here, which one rules the situation? If we put a number line here, negative 4 and 0, and we put greater than negative 4, that's going to be this type of diagram here to the right of negative 4, but also we have right of 0. And the one that rules the situation is this greater than 0, because this greater than 0 excludes everything that is less than 0. So that goes out. So x is greater than 0 is our governing exclusion. Okay, what we're going to do here is a strategy to rationalize. It's called multiply by the conjugate. It's something that you may not be too familiar with. I'm going to briefly explain what this is. So what a conjugate is, I'm going to rewrite this as square root of x plus 4 minus square root of x. What a conjugate is, it's the same expression, but using the opposite sign between them. So we're going to multiply by square root of x plus 4, and we have square root of x, so that's all the same, but we're going to put a plus sign right here. And we're going to do the same in the numerator, square root of x plus 4 and plus square root of x. Let me show you what happens here. I'm going to write a little box at the right to just demonstrate what a multiplying by a conjugate does. So I set up a little box here, and we're going to put on the top here square root of x plus 4 minus square root of x. On the side here we're going to put square root of x plus 4, and we're going to put plus square root of x. And just multiplying square root of x plus 4 times square root of x plus 4, we're going to get x plus 4. Negative square root of x times square root of x plus 4 is going to be negative square root of x square root of x plus 4. And over here in the lower left corner we're going to have square root of x times square root of x plus 4. In the lower right we're going to have negative square root of x times square root of x, which is going to be negative x. And so the lower left and upper right corner will cancel each other. So we're left with square root of x. We're left really, our answer here in this multiplication is going to be x plus 4 minus x. And so let's go ahead and rewrite our problem here. We have 8 times square root of x plus 4 plus square root of x. And in the denominator what we have is x plus 4 minus x. Well, x minus x will cancel each other, so we're left with 8 over 4 times, of course, square root of x plus 4 plus square root of x. And 8 over 4 cancel equal 2, so what we're left with is 2 square root of quantity x plus 4 plus square root of x. Pen is being a little glitchy right now. And comma x has to be greater than 0. Comma x is greater than 0. So this is going to be our answer to this problem here. So I hope this has been helpful to you. Good luck, and thanks for viewing.